Come on. Live. There we go. All right, today, 4/23/19. So today, the objective, what we're doing is looking at parallelograms. What we really want to look at is the characteristics of parallelograms. Okay, so you did your posters, and what I want to do is go off of your posters, plus I'll draw a picture. Here's my little maze here. Okay. That was nice, thank you. For being a freshman. So, if I draw a parallelogram, okay, I'm going to put one up to the side. Oh man, really? Okay, that thing is a mistake. That's a bluebie. Okay, get rid of that. So, what do we know? So, the definition. A quadrilateral. Quadrilateral with opposite parallel sides. Okay? And Dante, you didn't use, I like what you said, because he looked at the picture and he said, well, it's got four sides. So Dante's definition was a four-sided figure with opposite parallel sides. Awesome. Quadrilateral is a fancy word for four-sided figure. Okay, everybody got it? Easy. So what I want to do is mark my figure. Watch how I mark my figure, okay? I'll put an arrow here, arrow here. In fact, I'll put a double arrow here, double arrow. And by using my double arrows, I'm showing my picture just shows these two sides are parallel. That's why I use my arrows, okay? That's the symbol. And I'll use an arrow here and an arrow here. It's just a nice symbol to show that those two sides are parallel, okay? Now, if I label my parallelogram, let's see, A, B, C, D, right? Then by its definition, we've got some important information. Just by its definition, we could say that AB is parallel. That's my symbol for parallel. AB is parallel to CD, right? I mean, just by looking at, this is the way we say it. AB is, line segment AB is parallel to line segment CD. We also can say line segment AD is parallel to line segment BC, just by purely its definition, right? Now the characteristics. Well, let's take a look at the characteristics. Well, first of all, one, you guys said that opposite sides are equal. Okay? So, opposite sides are equal, so then I can mark my figure again. Okay, so maybe I'll take a different color and I'll mark it. Okay, so opposite sides are equal, so I can say that this side here is equal to this side here. And this side here is equal to this side here. In fact, you can see on the posters, by the double dashes, this side is equal to this side, and this side is equal to this side, okay? We also know by our other characteristics, we can say too that opposite angles are equal or congruent. So I can say that in this figure, I can mark it up if I want to. Let's see if I got a different color here. Oh, sure, this will work. I can say that angle C is equal to angle A, right? And let me do a double arrow here. And I can say angle B is equal to angle D, okay? So just to put it in, numbers, just numbers. Numbers, if this were 60, then that would have to be 60, right? If this were 120, then that would have to be 120, right? Just in pure numbers, right? Okay, does that make sense? Okay, now, third characteristic we had, three, was we could say that, I'm going to say adjacent angles are supplementary. Okay? So supplementary means they add to 180, okay? Add to 180 degrees, okay? Adjacent means next to. It's like your adjacent neighbor or your next door neighbor. It just means next to. Okay, so for example, in this picture here, I'll give you an example. If, say, this side was 70, this angle is 70, right? That would have to be 110, right? Because you have to add 180. That's 70, that would have to be 110, because you have to add 180. So let's mention. If that's 110, then that would have to be 70, right? It would have to be 70, because you have to add to 180. If that's 70, then that would have to be 110. It kind of makes sense, doesn't it, right? And then the whole thing makes 360. So, I mean, this isn't rocket science. It's easy, right? You guys agree? So then there's a fourth characteristic that has to do with its diagonals. And the fourth characteristic is that diagonals bisect each other. Okay, and I might draw another parallelogram just so you can see it by itself. But I'm going to draw another parallelogram right here so you guys can see it by itself. And these are our theorems in our book. But a theorem is just a fancy word for a math rule, right? So my diagonals go from corner to corner, okay? From corner to corner. That's a diagonal. And that's diagonal. And the word bisect means cuts it in half. So they cut each other in half, right? So it cuts it. This short line, the short diagonal, cuts this long diagonal in half. So therefore, this side here, this piece, is equal to this piece because it got cut in half. This long diagonal cut the short diagonal in half. So then this piece here would have to be equal to this piece here. They bisect each other, okay? Autumn asked a really good question. I thought it was great. She said, well, don't they all? In every figure like that, don't they always bisect each other? I thought, well, if they're congruent. She goes, if they're congruent. It was a good question. She goes, if they're congruent, don't they always bisect each other? I thought, well, and I remembered an isosceles trapezoid, which we'll talk about later. They'll be equal, but they don't bisect each other, okay? All right, so if we know that, take a look at example 1. So what do you know? I know that AB, right? I know that AB is equal to DC. I know that. You guys agree? Opposite sides are equal. AB is equal to DC. I know that. So I'm going to go, okay, x plus 18 equals 3x minus 2. Let's just solve for x, right? Minus x. I get 18 equals 2x minus 2, right? Plus 2. I've got 20 equals 2x. Divide by 2. And x is equal to 10. Okay, now I also need y, but I'll stop there. It says find the value. The question says find the value of x and y. Okay, so I've got x. So to find y, well, that's easy. If x is 10, let's plug it in. So take my 10 and plug it right there, okay? So if x is 10, then this side's 40. So that means y also has to equal 40 because the opposite sides are equal. Makes sense? It's like pretty easy, isn't it? This, we're going back. We did the hard stuff first quarter. Now we're doing the easy stuff now. Isn't that nice? So if you're worried about your grade, you can go, whew, I got a chance. This is easy stuff, right? Okay, now, example 2. Well, I know that opposite angles are equal, right? So I know that angle A is equal to angle C. So I know that angle A is congruent to angle C. Opposite angles are equal. So I can do that. So I can say, all right, 49 degrees is equal to 4x minus 37. Am I going too fast or am I okay? Am I doing okay?
You're fine.
Okay, let's just solve for x. So I'm going to go plus 37, plus 37. Oh, what's that? 86, I think. Yeah. 86 equals 4x. Divide by 4. What's 86 divided by 4? 21.5. Okay. Now, if I know that, then I'm going to take that answer and I'm going to plug the 21.5 right there, because that's what x is equal to, right? So instead of 4x minus 3 equals a 1/5 y, because that's what I really have. These two have to be equal. I've got a 4 times a 21.5 minus 3 equals a 1/5 y. So I'm trying to figure out what this side is. What is 4 times 21.5 minus 3? So this is 83. This is 83. So this side is 83 by plugging in plug the 21.5 in. I went 4 times that times the 21.5 minus 3, and I got 83. So this side's 83. So the 1/5 y equals the 83. Okay. So let's solve. To get rid of and solve for, I'm going to multiply. I'm actually going to multiply by 5. Because if I multiply by 5, it'll cancel it. Multiply this side by 5, right? Let's see what's 83 times 5. I get 415. So y is equal to 415. Okay? So all it is just algebra, using what you know. Using what you know, but it's just algebra. Okay? Ready to turn the page? Am I going too fast?
No.
So wait, 415 divided by 5 would be 83.
Yes, try it.
So DC would be 83.
Yes. Yes. Because it has to be 83, because if this side's 83, this side's 83. Yes, totally right. Good job, Derek. Okay, turn the page. Okay, now on the back side. All right. Example 3. Let's graph it. So 0, 0. There's A. Okay, 0, 0. There's A. 1, 3. There's B. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4 is C. And D is 1, 2, 3, 4, 5, 1. Okay? That looks like a parallelogram to me. Okay, just a second. I'm going to show you something just astounding. You're going to be amazed. You're going to be amazed. You want to be amazed? Okay. I know it's parallelogram. You know why? Check it out. The slope up 1 over 5. The slope up 1 over 5. Same slope, parallel. Whoa. Check it out. The slope is up 3 over 1. Up 3 over 1. Same slope. They're parallel. Whoa. It's got to be a parallelogram, isn't it? Now, what about the diagonals? Let's draw them in. So my diagonals are going to be, let's see if I can draw this in nicely. My diagonals is from corner to corner, right? Vertex to vertex. And vertex to vertex. I think I found my intersection. So it says find the coordinate of the intersection of this parallelogram. There it is. 2, 2. Thumbs up?
That's 3. So it takes 3
Oh man. Thanks guys. 3, 2. Thank you, thank you, thank you. Does that seem easy? This is easy stuff. Muy fácil, see? Okay. Example 4. Okay, find a fourth point, and this is parallelogram ABCD. If A, so A is 1, -1. There's A. B is 0, 2. C is 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay. There are 4.
I have one.
There are, yes. There are 3. There are 3 possible spots. Here. Okay. Now visualize this. Here could be another one. Really. You could have one here. And even way up here. Let's take the easy one, Max. What'd you say?
The 5-1.
Okay, Max said the easy one's at 5, 1. 1, 2, 3, 4, 5, 1. How do I know Max is right? He is right, but how do I know he's right? Check the slopes, right? Check the slopes. Up 1, 2, 1, 2, 3, 4. Up 1, 2, 1, 2, 3, 4. Down 3, 1. Down 3, 1. Nice job, Max. I totally agree. Does this seem easy, you guys? Okay, so your little